All right, we're going to move on from parallelograms and we're going to start talking about a different kind of quadrilateral. Today we're going to talk specifically about rectangles. But even though we've moved on from parallelograms, a rectangle is just a parallelogram that has four right angles. So all of the rules for a parallelogram apply to a rectangle, with the additional fact that a rectangle has four right angles. So all four angles are congruent. We have a couple of properties of rectangles. They're two theorems and they're not too complicated. The first one says that if a quadrilateral is a rectangle, so that means I tell you this is a rectangle, ABCD is a rectangle, then it is a parallelogram. So if you see this, you know that parallelogram ABCD. So ABCD is a rectangle, it's a parallelogram ABCD also. If a parallelogram is a rectangle, then its diagonals are congruent. So from B to D is congruent to AC. Okay, that's a little different than the parallelograms. Remember, they bisected each other. So in a rectangle, they're congruent and they bisect each other because they're a parallelogram. So again, since a rectangle is a rectangle inherits all of the properties of parallelogram. So for this section, when we're talking about rectangles, we want to remember that since it's a parallelogram, so I'm going to put a little parallelogram symbol out here. Remember that the opposite sides are congruent, and since it's a parallelogram, the opposite sides are parallel. Since it's a parallelogram, the opposite angles are congruent. And since it's a parallelogram, remember the consecutive angles are supplementary. And lastly, since it's a parallelogram, remember that the diagonals bisect each other. Okay, that's very important that you know that they bisect each other. So write that down. Now our two new properties that are specific only to rectangles are that the diagonals are congruent. And our last one is way up at the top, the definition that said it has four right angles. So a rectangle has four right angles. So these are the things you need to know about rectangles. Everything about a parallelogram, plus the diagonals are congruent, and it has four right angles. So take a quick look at a couple of examples of type of problems we'll do with rectangles. So a woodworker constructs a rectangular picture frame so that JK is 50 centimeters. So JK is 50. And JL, that's this distance right here, is 86. And our problem tells us to find HM. Well, HM is from here to here. Now, because our shape is a rectangle, they tell us that, we can use all our properties. So one of our properties says that diagonals are congruent, right? So if JL is 86, it's congruent to KM, which is also 86. Well, a property of parallelograms, which all rectangles are, tells us that diagonals bisect each other, right? Diagonals bisect each other. And because that's true, we know that this distance, HM, is the same as this distance, KH, right? But we also know that this distance, HJ, is the same as this distance, HL, and that all four of them are the same length because JL and KM are the same length. So if they're both split in half, all their halves would be the same length. So 86 split in half is 43. Okay, so all of these are 43. So HM equals 43. Not too bad, right? Okay, example 2 says quadrilateral JKLM is a rectangle if the measure of angle KJL, so KJL, so that is this angle right here, is 2x plus 4. Okay, and I'm not going to mark on it yet. The measure of angle JLK. Well, JLK is this angle, right? So we have this angle, right? And then we have this angle. I'm going to mark it with 2 marks because they're not the same, right? But what we know about those 2 angles is that because this is a right angle, because all rectangles have right angles, that these 2 angles here have to add up to 90 degrees because the 2 acute angles of a right triangle always add up to 90 degrees. So 2x plus 4 plus 7x plus 5 equals 90. Then we can combine like terms and get 9x plus 9 equals 90. Subtract 9 from both sides. 9x equals 99. So x equals 11. All right, not too bad, right? So here's an example for you to try. Go ahead and work this one yourself. It says angle RTU, so RTU, that's this angle, and angle TRU, that's this angle. Here's our right angle. So these 2 would have to add up to 90, so go ahead and work that one in your notes yourself. And now we'll move on to example 4. Spoiler alert, you should have paused it, worked example 3, then unpaused it, and come back to this one. But anyways, here we are, example 4. It gives us the points for our quadrilateral. And now it says determine whether PQRS is a rectangle using the distance formula. So the first thing we need to do is put all these points on our graph. So negative 5, 3. Negative 5, 3. So that's P. Then 1, negative 1. Okay, that's Q. Then R is negative 1, negative 4. That's R. And negative 7, 0 is S. And now our instructions say to prove that this is a rectangle, right? Show that this is a rectangle using the distance formula. Well, if I figure out this distance and this distance, it's going to be hopefully congruent. And if I figure out this distance and this distance, hopefully they'll be congruent. But even then, that's not enough to say that it's a rectangle because that's just telling us that it's a parallelogram if the opposite sides are congruent. But something new for rectangles is that the diagonals have to be congruent. So to prove these diagonals are congruent, we're going to use our distance formula, as that's what it says to use, right? So that says that x2 minus x1 squared plus y2 minus y1 squared, right? That's the distance formula. And now our diagonals are PR and SQ. So we're going to do square root, and we're going to start with PR. So x1, y1, x2, y2. So negative 1 minus negative 5 squared plus negative 4 minus 3 squared. And that's going to equal the square root of, see, negative 1 plus 5 is 4 squared, so 16, plus negative 4 minus 3 is negative 7 squared is 49. So 16 plus 49 is the square root of 65. Now we don't need to know what the square root of 65 is because it didn't ask us how long it is. It just asked us if they're both the same length. So when we come down and do SQ, okay, we're going to SQ. So SQ, x1, y1, x2, y2. So x2 minus x1, 1 minus negative 7 squared plus negative 1 minus 0 squared. Okay, 1 minus negative 7 is 8. 8 squared is 64. Negative 1 minus 0 is negative 1. Negative 1 squared is 1. 65, square root 65. So those are the same. So PR equals SQ. Therefore, PQRS is a rectangle. That's that.